Hello and welcome to the BS Academy. So recently IIT Bombay has changed their syllabus a little bit to the each branches. So according to the new syllabus, we have made these charts in our best possible ways, and these charts basically give you an idea how to prepare your own charts, because ultimately you have to make your own charts of every subject, and after that you will get that confidence. So basically these charts will give you the ideas and perfect information after referring all the reference books. The second subject is production technology. In this subject, the second chart is for the sheet metals, and sheet metals includes the different sheet metal operations as well as the different calculation of the drawing load and the defects in the drawing. As you can see here in the diagram, that different operations like trimming, slotting, nibbling, parting, notching, lancing and holes. So start one by one. The main two operations which are most important for the examination is the punching and the blanking operations as well as the searing. So in the punching, here the seared portion is scrapped, and in the blanking the seared part is useful. These are main two different, but the important thing is there. So for the punching process, here one note is there that as will increase the I, the F will reduce, means the force required is reduced for the punching operations. Then you can remember like the PCD and the BCD process, means for the clearance the size of punch is equal to size of hole for the punching operations. PCD denotes that in the punching operations clearance will be given to the die, and in the blanking operation clearance will be given to the punch. So for the punching process, here size of die is equal to size of hole plus 2 into clearance, and size of punch is equal to size of hole. Then radial clearance is equal to 0.0032 into t into under root tau, and diametral clearance is equal to 0.0064 into t into under root tau. Then for the blanking process, size of die is equal to size of blank, and size of punch is equal to size of blank minus 2 into clearance. Then after the third process is the shearing process. So in the shearing, K is equal to penetration upon the thickness, means KT by T, which is equal to stripping constant. Then maximum force required for the shearing, F max is equal to pi into D into T into tau S. Then F max is equal to 2 into L into B into T into tau S, and WD is equal to F max into KT. So you can write that F max into KT is equal to F into KT plus I. Then stripping force, FST is equal to y into d into t into k, where k is equal to kt by t. Then angular clearance is equal to 0.25 to 0.75 degree per side. Here notice that the 10 mm die hole is punched from a sheet of 3 mm thickness, then the operation is punching. And if 20 mm disc is punched from the 3 mm thickness sheet metal, then the operation is blanking. Then T less than 5 to 6 mm, which is known as the sheet, and thickness greater than 5 to 6 mm, which is known as the plate. Then punching force, Fp is equal to pi into D into T into tau S for the shear strength. Then Fp is equal to D into T into S upon under cube root of D by T. Then shear force Fs is equal to pi into D into T square into Kt upon I, and Fp is equal to Fp into Kt upon Kt plus I. Then Fb is equal to Fb max into Kt upon Kt plus I. So these are the some equation which is useful in the examination. Directly you can put this equation and find the values of the respective terms. Then fourth one is trimming, which is mostly used in the drop forging and die casting process. Then fifth one is shearing, is used in blanking or punching. The edge of the blank hole is not perfectly clean, then shearing is used, which removes the burr left on the product. Then sixth one is nibbling process, which used to removing the material in the small increments during the specific contour cutting in the sheet metal. Then seventh is notching process. It is used to cut the small portion of the edges. Then eighth one is the piercing or the punching, used for the making holes in a sheet. Then ninth is blanking. Removes the desired portion by the punch from the sheet metal. Then there is a term like spring break or the elastic recovery. In that, total strain produced during deformation is equal to the elastic strain plus the plastic strain, and the elastic strain recovered. Then this phenomena is known as the elastic recovery. Then spring break is directly proportional to 1 upon E and proportional to sigma y and proportional to the amount of the deformation. Then types of die. First one is the simple die, second one is progressive die. For the progressive die, the equations like F total is equal to Fb plus Fp, and here note that Fb max is greater than Fp max, means the force required for the blanking is greater than force required for the punching operations. Then third one is the compound die, in which two or more operations take place at one station and it is more productive process. Then fourth one is the combination die, in that at same time blanking and piercing both are producing in one stroke only. Then calculation of the drawing load for the cup drawing and dip drawing processes. So WD means work done is equal to E1 is equal to F1 into H1. Then WD is equal to E2 is equal to F2 into H2 minus H1. Then FD is equal to pi dt sigma y into capital D by D minus K. Then H less than D by 2 cup drawing, and if H greater than D by 2, then dip drawing is there. Here note that H greater than or equal to D by 2 is there. Then for the cup drawing, H by D is less than 0.5 and H by D is greater than or equal to 0.5 for the dip drawing processes. Then Fd is equal to pi dt into sigma y if K is not given there. After that, first one is the cup without flange. For that process, d square is equal to d square plus 4dh and h is equal to d square minus d square by 4d. Then cup with flange, d square is equal to d2 square plus 4d1 into h and h is equal to d square minus d2 square by 4d1. The respective terms d, d1 and d2 you can see from the diagram there. After that, there is one table is there for the blank diameter. Then if d by r is greater than or equal to 20, then d is equal to under root d2 square plus 4d1 into h. Then d is equal to under root d square plus 4dh minus r by 2, where d by r is equal to 15 to 20. Then d is equal to under root d2 square plus 4d1h minus r. And the third one is d is equal to under root d square plus 4dh minus r, where d by r is equal to 10 to 15. Then d is equal to under root d2 square plus 4d1h minus 2 into r. Then stresses in the wall of the cup. So uniaxial means the tensile in the wall of the cup, and biaxial means the tensile plus compressive stress into the flange of the cup. Then there are two equations for the first row and the second row. For the first row, sigma 1 is equal to f1 upon pi by 4 into d1 square minus d1 minus 2t square. Then for the second row, sigma 2 is equal to f1 upon pi by 4 into d2 square minus d2 minus 2t square. Then reduction ratio r is equal to d minus d by d into 100. Then for the first row, the draw ratio is equal to dr, which is equal to d by dn, where n is equal to 1, 2, 3. Then there are some thumb rule for the reduction when reduction percentage is not given. So for the first row, the reduction will be 50%, then second row reduction will 30%, for the third row reduction will be 25%, for the fourth row reduction will be 16%, and for the fifth row reduction will be 13%. Then linting draw ratio, LDR is equal to capital D by D mean, where capital D for the blank and D mean for the cup. Then there are drawing defects are there. First one is the wrinkling. In the wrinkling process or wrinkling defects, the wrinkles may appear either on the flange or on the wall of the cup, or sometimes on the both the flange and wall the wrinkles may be appear. It can be avoided by the draw beads or by increasing the pressure of the blank holding. Then the second one is the shearing. In this defect, the anisotropy ears or loops are generated at the length of the curvature. Then the number of ears is equal to 2 raised to n, where n is equal to 1, 2, 3. Then the third one is the orange wheel, in which the large size grains of the sheet metals. Then the texture of the draw cup appears like the orange peel. Then after the fourth one is the fracture or tearing, in that due to the much pressure or improper design, this type of defects will be appear, and it appears at the neck or the bottom of the cup. And the last one is mixed type defect, in that the misalignment of the line uneven flange appears in the drawn cup. Then there are two processes are like spinning and ironing. So the spinning is the cold drawing process. For that process, Tc is equal to Tb into sin alpha, where Tc is equal to cone thickness, Tb is equal to blank thickness, and alpha is equal to semi-mandrel angle. Then ironing is the process of thinning the walls of the drawn cylinder by passing it between the punch and die, where T2 less than T1. For example, brass cartridge cases, thinned wall beverage cans. Then there is bending load calculation for the equation that Fb is equal to C into B into T square into sigma U by W, where B is equal to width of the stroke, sigma U is equal to ultimate tensile strength, W is equal to width of the die opening, C is equal to die opening factor, and T is equal to stroke thickness. One more equation is there, like LB is equal to alpha into R plus KT, where length of the neutral axis in the bend zone, that R is equal to bend radius. So LB is equal to length of the neutral axis in the bend zone, and R is equal to bend radius. Then in the edge blending, the diagram is there. For V blending, the diagram is there, and U bending, the diagram is there. Then there is the note for the clearance die opening factor for the E type, V type, and the U type blending processes. So for the W less than 16T, for the E type 0.67, then for V type 1.33, and for U type 2.67, and for the W greater than 16T, for E type 0.60, for V type 1.20, and for U type 2.40. Then under similar bending parameters, FE gem, FV gem, FU is equal to 1 gem 2 gem 4. So this is the ratio in the terms of EV and U. Then there are two examples for the punching and blanking operations, in which you can use directly the equation which we have discussed earlier in the starting. Then after, one note is there for the compounding die, F total is equal to F max from the FV or FB, where FB is equal to pi into D into tau s, and FB is equal to pi into D into tau s. Then there is one example for the drawing operations requirement. If given that the T is equal to 1.5 mm, H is equal to 7.5 mm, and we have to produce the D is equal to 5 cm cup, then we have to use the equation of the draw ratio, which is equal to dm before divided by the dm after. So for the first D1 days, 13.32 by 1.8 is equal to 7.34, which is greater than 5 cm. So we have to repeat that once again. Then D2 days is equal to 7.34 divided by 1.8, which is equal to 4.08, which is less than 5 cm. So at least we require two drawing operations here. H1 is equal to D square minus D1 square by 4D. So you can find the value of H1 from that and find the values of F1 and E respectively. Then the third example is for using the equation D is equal to under root dn square plus 4dh1. This is used for D1, D2, D3, D4 and D5 when the value of diameter is less than the required diameter. The n is equal to your required answer, which means that much drawing operations you require. Here in the example you can see that there are 5 times we have used that equation, and after that the value of n is equal to 6, means minimum 6 drawing operations we required for the given example. So this is all about the second chart of the sheet metal, in which there are main 5 to 6 important formulas and some drawing defects, and the spinning and the ironing process as well as the bending load is covered. So we'll hope that from this chart you will gain some important formulas. So if you like this video, please do like and subscribe to the BS Academy channel, and press the bell icon for the upcoming chart, which is very most important for the GATE examination. As you all know, the chapter is metal cutting, and from which in the every GATE examination there are 4 to 5 marks questions will be there. And also share this video to all your friends who is preparing for the GATE examination 2021. Thank you so much.